Right now we're going to consider a function f of x equals x cubed minus 8 over x squared minus 5x plus 6. And we are going to graph that. Okay, let's first of all talk about whether this has any horizontal asymptotes. So when we're looking at horizontal asymptotes, or the possibility of them, you look at lead term over lead term and consider the degree. So this particular function has a higher degree on the top than the bottom by 1. So that means we're going to actually not have a horizontal asymptote, but we are going to have a slant or oblique asymptote, all right, which we are going to find using long division. Just as a reminder, though, if these two degrees had been the same, then your asymptote would be lead coefficient over lead coefficient. And if the degree was larger on the bottom, if you think of Bobo, bigger on bottom, y equals 0, that's what this is for. Bigger on bottom, it goes to y equals 0. But that's not what we have here. What we have here is the degree is bigger on the top, so there's an oblique asymptote. So the best way to find that would be, let's factor out the top, x minus 2, and this is, the top is difference of squares, so you have to think back to your intermediate algebra class and remember the formula for that. 2x plus 4. And then the bottom is just a trinomial. If I factor that out, I get x minus 2, x minus 3. Okay. Now, these two are going to cancel out, which, by the way, that means there's going to be a hole at 2, which I'm going to get to later. But for now, we're going to use long division to divide these two right here, okay? But actually, since this is what we can do instead of actual long division, because not everybody likes it, is we can use synthetic division on this one. So if I take in the numerator the lead coefficients, I'd get a 1, a 2, and a 4. And then remember, for synthetic division, you drop that first number down, and then I'm going to multiply it by the number in the box, which is 3, and put the answer here. Add those two numbers. 2 plus 3 makes 5. And then that 5 gets multiplied again by the 3 in the box, so it's 15. The number that goes here, 19. Okay? What that means is that when I divide the numerator by the denominator, I am left with 1x plus 5 plus the remainder of 19 over x minus 3. Now, this denominator is going to tend to be towards 0. So this is my oblique or my slant asymptote. Okay, so you got that. Also, you want to talk about vertical asymptotes. Okay, if you look at the denominator there, so vertical asymptotes, okay, your excluded values from looking up here are that x cannot equal 2 and 3. But the 2, remember, that was canceled out. That factor right here was canceled out with this one. So there is going to be a hole at 2, but a vertical asymptote at 3. So x equals 3 is the vertical asymptote. So we have an oblique asymptote and a vertical asymptote. All right, so let's get sketching. Let's go to another page and remind ourselves you have an asymptote at y equals x plus 5 and x equal 3 are the asymptotes. So if you graph that, okay, 1, 2, 3, 4, 5. Okay, sorry about that. let's do this one first. Start on the y-axis at 5, up 1, over 1, up 1, over 1. This right here is my slant or oblique asymptote. Okay, there it is. So that's this guy. And then x equals 3 would be right here. That's this guy. All right, now the actual graph, if you go, sometimes people need to pick a point, but remember the graph's going to come in towards the asymptote. So it's basically going to start here and go down that way. Now, if you want to confirm that, just pick any point, like x equals 1 or -1 or -2, and you can get a couple points on there, and then you kind of connect the dots. Similarly, if you put in x equals 4, you get a dot up here, finding out that this is going to go, oh, pen's not working, hold on, like kind of like this up here. So that is your graph.